Today's vocabulary of the day, reciprocal. This is a word we talked about way back when we learned how to divide fractions. The formal definition is the multiplicative inverse. In other words, the product of the two numbers in one. A little more practical terms, if we think back to when we learned about fractions, we did use the reciprocal. For example, if we started with 2 over 3, the reciprocal, what is we going to have to multiply this by to get 1, is to flip that upside down and it becomes 3 over 2, which would end up giving us 1. Any number, for example 4, the reciprocal would be 1 over 4. Remember, we can make any number a fraction by putting it over 1, and that product, once again, would be 1. Today we're going to talk about zero and negative exponents. To talk about that, I want to look at patterns first. If you see the patterns, it sometimes helps you understand some of the rules we're going to talk about. So let's start with our 2's. We have 2 to the first, 2 to the second, and 2 to the third. 2 to the first would be 2, 2 to the second would be 4, and 2 to the third would be 8. And if we talk about the pattern as we go down that table, we are multiplying by 2. More importantly, I want to talk about what pattern happens when we go up the table. What are we doing? The opposite of multiplying by 2. So going up, we would be dividing by 2. So I want to go back to my table and use that pattern to answer a couple of these questions. And that's going to help us with today's lesson. So 8 divided by 2 is 4. 4 divided by 2 is 2. 2 divided by 2 is 1. 1 divided by 2 is 1/2. And 1/2 divided by 2 would be 1/4. And that's what we're going to focus on today. Anything to the 0 power is 1. And if you look closely at these two, they are using reciprocals. 2 to the negative 1 is the same as 1/2. 2 to the negative 2 is the same as 1/4. So a couple of things you need to write down and make sure you have in your notes. Anything to the 0 power is 1. When we're talking about negative exponents, we want to write them in their best form, and that would be to use the reciprocal. This goes along with the key concepts in your book. These key concepts are on page 449. So using those key concepts, we want to talk about here the examples that we have. And we have 4 examples, and I'm going to focus on the first one, 2/3 raised to the 0 power. We just said anything at all raised to the 0 power is going to give us 1. I'm going to jump down here to problem number 4, -1 to the 0 power. Should be pretty easy to simplify. Anything to the 0 power is 1. We're going to go back and look at number 2 here. We have -8 raised to the -2. Let's turn this into a fraction. The way to get rid of this negative exponent is to use the reciprocal. So I'm going to flip it upside down, and I'm going to have 1 over -8 to the +2. If I work this out, 1 over -8 squared, -8 times -8 is 64. I want to highlight here that this negative sign isn't going away. The reciprocal changes my exponent from negative to positive. The sign on the number does not change. So our answer here should be 1 over 164. Back up here to problem number 3, we have 1 over 2 to the -3. To get rid of that negative exponent, get it into its best form, we're going to use the reciprocal. The reciprocal would be 2 to the +3 over 1. 2 to the 3rd power, 2 times 2 is 4, times 2 again would be 8 over 1. And of course, in its best form, it would simply be 8. Check, make sure we did it correctly, and let's move on. These are key concepts in your book on page 450. We're going to use those as we review these examples that go along with example 2 in your book. So, looking at problem number 1, we have, it's not number 1 actually, it's problem number 5. So I'll label it as such here. 1 over 4 to the -3rd power. To get rid of that exponent, make it positive, which is our goal. We want everything in its best form. We use the reciprocal. So it becomes 4 to the 3rd over 1. 4 times 4, 16, times 4 again, 64 over 1, which in its best form would be simply 64. Looking at example 6 down here, we have 5 to the -3rd, all raised to the -1. This is where we're going to, and I'm actually going to try and rewrite that because it didn't look like a -3. It looked like 53. 5 to the -3, all of this raised to the -1. Raising a power to a power. Remembering the rules that we learned, we're going to multiply. So -3 times -1 becomes 5 to the positive third power. 5 times 5 is 25. Times 5 again would give us 125. Going up here to example 7, I am multiplying and I have like bases. The rule says if I'm multiplying and I have like bases, I'm supposed to leave my base and subtract my exponents. Add my exponents. 5 plus a -5. Multiplying like bases, we want to add our exponents. 5 and a -5 is going to leave us with -3 to the 0 power, which we all know anything to the 0 power is 1. So check that. Back down here I didn't check it, but we did get it correct. Example 8, we're dividing. When we're dividing with like bases, the rule is to subtract your exponents. So 6 to the -2 minus 2 becomes 6 to the -4. If we change that into a fraction, we would use the reciprocal to get it into its best form. And I believe 6 to the 4th power is 1,296.